One of these electric motors runs electricity from the wall into rotational energy. Now, the way the motor spins using electricity is through the windings. You know, it's basically creating magnets. Everybody knows that. And now, the way the windings know what to do, because there's no controller inside of here, is through the capacitors and the centrifugal switch. So the capacitors basically are what create the phase shift that basically is pulling the magnets like on off, making the shaft spin. And it only uses the start capacitor at the beginning though, because once that motor is spinning, it uses its own momentum to keep it going. It's also more efficient to run it off of only one winding using the run capacitor. So now the centrifugal switch, momentum activated switch, it's basically in constant pressure against one of these plates. So when the switch is not spun up, it's connected to the start capacitor. When it's spinning, it's disconnected the start capacitor. Now, the way you can rate your capacitors for a motor is if you take the horsepower multiplied by 2,650 divided by your voltage. That'll give you your like the microfarad rating for your run capacitor. Alright, sorry, I had to work it out off camera just to make sure I can do it quick enough. So we've got 5, we're going to give our horsepower rating of 5. We're going to multiply that by 2,650. That'll give us 13,250. We're going to divide that by our voltage, which in this case is 220. That'll give us about 60.2. So that 60.2, that'll give us our run capacitor microfarad rating. Then to get the start capacitor, we're going to multiply that by 5. That'll give us around 301. So that will be our start capacitor. That'll be our run capacitor. So 301, 60.2. Everything else about electric motors. Single phase is the only one that needs the capacitors. 3-phase doesn't.